Someone left a really good comment on my last video. They said, I'm 18 and I'm trying to choose between medicine and computer systems engineering. With AI advancing so fast, which is safer long term? I love this question, but I think it's the wrong way to frame it. So, in this video, I'm going to walk you through exactly how you can use AI inside medicine and engineering to become way more valuable instead of just being scared I will replace you someday. Before we jump into medicine and engineering, we need to clear up how AI actually changes jobs. Most of the time, AI does not delete an entire job, it just slices off certain tasks. I'll be honest, in both healthcare and engineering, is getting really good at it. For things like pattern recognition, repetitive and structured tasks, AI is really getting really good. For even things like documentation and doing basic analysis, most of those jobs, AI can really do them. So, for any job that is repetitive, that you need to do some sort of analysis or read through a document, you technically can use AI to do those jobs. For example, in medicine, it might help to read scans or summarize a patient's chart. In engineering, it might write boilerplate code or even suggest test cases for code. Or for architecture, it can help you come up with designs. Even for UI and UX, it can help you do all those designs such that you don't have to spend your time doing the design yourself. And you would have multiple, creative ideas. We think of AI like a super fast intern. It never sleeps, super useful, but you still need a responsible human, someone who really knows the job, who has the bigger picture, to carry all the responsibility of delivering that product. Whether it be legal, or meeting the requirements of your client, you still need someone who has a deeper knowledge and understanding to carry all that responsibility and make the final decision, make the final calls. That's where you as a human using AI really comes in. So instead of asking which degree is safest, a better question would be, how do I become AI native in my chosen career or in any field I decide to go in? AI native just means you tools, you understand their limits, and you use them to multiply your impact. Rather than spend time doing these repetitive tasks, you use AI to do all those tasks and just focus on the core aspect of the tasks. Let's walk through what that actually looks like. First in medicine, and then in computer science and systems and all of the engineering. I want to use the computer systems and engineering to cover all of the engineering field. So imagine you're a doctor in a busy clinic. You have lots of patients coming in and going out. Before a patient would ever walk into your clinic, you can have AI do some of the tasks that would have been done before the patient even walk into the hospital. You will see more and more tools where patients enter their symptoms online or through a mobile app. The AI groups all of these inputs by urgency, red flags, maybe even it will suggest a probable list of conditions. Give you, as a doctor, it will give you an idea of what to look out for and how to attend efficiently when the patient walks in. So your job as a future doctor, isn't to blindly trust the entire list that the AI will give you, but rather it's to use it as the starting point. Like I said, you're so prepared before the patient walks in, and having that list would guide you because you've reviewed it, looked at it critically before the patient walks in. So now you're not all over the place when the patient walks in. Exactly questions to ask the patient. Does this actually make sense for the patient? You're asking yourself that question. What important question has the AI completely missed? These are the things that you, as a doctor using AI, would now focus on in the future. So you walk into the room already prepared with sharper questions instead of starting from a blank page. And when you're with the patient, traditionally, doctors and maybe even nurses spend a painful amount of time taking notes or typing notes into the electronic health records. Most of the time, when you go see a doctor, they're always taking notes, or probably they have someone. Most times, I see them typing into the computer to store your records and update your record. But that is something that AI can really do. AI can just sit in the background, listen to your conversation in a secure system that is designed for that purpose. And then it will generate a draft note for the doctor. So you, as a patient sitting with a doctor, would have the doctor's full attention, while AI just does all of the other work that the doctor would have been doing, typing behind the scene in the background. And afterward, the history of the patient's illness is ready for the doctor. AI can even suggest possible medications. If there are any physical exams, the AI can suggest that, and can even draft a preliminary assessment and plan for the doctor to now review and say, okay, we would go this way, or even make adjustments. That's something that I think AI can really do going forward, working with doctors. So, again, what does an AI native doctor do in all of this context? Which is how I see that most doctors will become in the future. What you do is you talk to the patient like a real human, make real eye contact, and then you quickly review and edit the AI generated documents and notes afterwards. AI cannot be or act like a human. Only humans can do that. That's where you, as a doctor, will shine over AI, but using AI as an assistant. So instead of 20 minutes of you typing and taking all that notes, you would eventually spend, say, like 3 minutes correcting and double checking all of the notes, the medication suggestion, and the plan that the AI has generated. Remember, because the AI has access to vast knowledge of information treating similar patients, it would suggest near good information to you. And that will free up the time to actually care for people and not fight software or fight issues. Sometimes you go into the hospital, the doctor is trying to on their computer and it's not working. It can happen in the case of AI, but if it's always there, you don't have to think about it. This is where people can get scared though. If AI can read their CT scan, do we still need doctors? But like I said, it's already quite good at looking at things, CT scans, medical records, x-rays, and the likes. Because those things are all based on computer information and computer knowledge. But what AI cannot do is have that human to human touch, that to human communication. So you, as a doctor or a future doctor, you want to focus on enhancing that aspect of you, that human to human communication. When you have your patients come, you want to be more friendly, you want to be more welcoming, and let AI do all of the distracting, I call it distracting work, you would have been doing. Also know that real diagnosis is more than just reading MRIs or X-rays or reading one image. It's the patient story, it's the other illnesses that they've had or experiences even before they walked in, kind of medication, social context in which they exist or live, the lab results over time. An AI native doctor uses all these tools like a second pair of eyes. If the AI disagrees with you as the AI native doctor, that's a signal to slow down, double check your work, maybe order one more test, not to just surrender to AI's judgment. And remember this, you are the one putting the whole puzzle together. So, what you should focus on if you're thinking of medicine and you want to future proof yourself, first, communication and empathy, like I've mentioned before. You look into the eyes of patients, you're more welcoming, you smile, because now you're spending less time doing all of the other work that you usually would have been doing, like typing and filling in the medical records. Because I can also help you, do all of the summarization of the lab results. Second, critical thinking and ethics. You need to understand that AI models can be biased, they can be wrong, and they can over or underdiagnose certain group of people. Because the data they use in training these models will determine how eventually the AI will bring out results. So your value is knowing when to trust the AI tool, when to question it, and ultimately when to ignore it. It's not to use it to replace you, which is what this video is all about, but to be the one that become the orchestrator of whatever, how many AI tools you use. If you build these human skills and layer AI on top of it, you're not competing with machines or any kind of AI. You're ultimately directing them. Now let's switch to computer systems engineering. The fear is a bit different. You can code, do we still need engineers? Software engineers? My answer is we absolutely still need software engineers. But the job will look different. Honestly, it will look really different. It's already looking different. Let's walk through what AI native looks like on the software engineering side, which is where I find myself. If you're 18 and going into engineering, AI can be your fastest teacher. Gone are the days where you would spend time watching YouTube videos and tutorials. You can learn from there, but you can use AI to fast track it. You're stuck on how a particular network protocol works. AI to explain it to you, like you're new. And then again, you ask it to explain it to you, an advanced user. You're trying to design a system with multiple services talking to each other. Maybe it's a backend service, or for you're writing a UI for a mobile app. You can sketch your idea on a piece of paper and ask the AI to suggest different architectures, the pros and the cons, and even potential bottlenecks that you will face while you're coding it. Before, it would just mean that you have to just go straight and do all of this yourself. But now you can ask AI to do all that for you. You still need to decide what actually is appropriate for whatever systems you're building. But suddenly you have this brainstorming partner that never gets tired of your questions. The days we used to always go to Stack Overflow to get answers, or we just Google it. So day-to-day coding co-pilots are becoming the standard. Now they can generate boilerplate code so easily. They can easily suggest tests for you. If you write a code, you want to write tests for it, it's super easy to do that. Once you know all of the libraries or you have it in your application, you can easily spot obvious bugs and lint errors. You can use AI to help refactor your messy code. Although my suggestion is you want to be careful in this area because it can refactor you into something you never intended. If you're AI native, you don't just let the AI vomit out code you don't understand. You want to be careful of this. You use it to you use it to speed up things you already conceptually get. I know what I want this function to do. I just don't want to type all of it. That's a very good context to use AI. And once the AI spits the code to you, all you need to do then is read through it line by line and make sure that it actually behaves the way you intended it. Especially when you work in an enterprise environment. You don't want to commit code that would embarrass you at the end of it. So instead of spending an hour writing repetitive code, you spend an hour designing better systems and verifying that the AI has produced the exact code that you want. Computer systems engineering isn't just writing code alone. It has to do with operating systems, networks, hardware interactions, reliability and security. How do you ensure that you build systems that are reliable going forward? You can use AI to do all of this. It can help you analyze your logs at scale, so you have logs that you're logging from your system. I can do all of that. And quickly it can flog all the anomalies. It can even suggest configuration changes for you. It can help you simulate and load scenarios. But the way that you would use AI in all these circumstances and environment is try to be specific. You want to give AI the correct context. If you try to add so many contexts at the same time, you'll get the AI confused. So an AI native systems engineer would use these tools to see patterns humans would miss, but still understand what's happening under the hood. You want to ensure that if you're writing with Java or JavaScript, you understand the syntax, you understand the language. If you're designing a system for a consumer, you want to ensure that you use that story, the journey that the user will go through, and then have AI focus on writing the syntax, delivering key parts of the application for you, functions, method, classes. If something weird happens in production, you cannot just say, "Oh, the AI said it's fine." You get fired in testing. So ultimately, you're responsible for understanding why a system failed and how to make it more robust next time. So my advice for you is understand what you're doing. That's why you still need to study this, go to college or university, however you want to study them so that you them in and out. And let AI do all of the, again, repetitive tasks for you. So how do you make yourself hard to replace as an engineer in an AI world? We've spoken about how you can do it with medicine or as a doctor, but how do you do that as an engineer in the AI world? The first is you need the deep fundamentals. Things like operating systems, networking, databases, security, distributed systems. You need to have a little bit of understanding of how these systems work. AI can help you code, but if you don't know what a race condition is or how networks actually behave under load or under stress, you won't even see the AI is suggesting something unsafe. So you won't even know what AI is telling you is not true. So I would say focus on concept when it comes to computer systems engineering. Focus on key concepts. What are race conditions? What's a class? How do you define a class? What is when a system is under stress or facing load? How do you know? The second thing is you need to understand systems thinking and communication. So a lot of value comes from translating messy human requirements into clean technical designs and then explaining the trade-offs to non-technical people. Oftentimes, this is the part that takes the longest to resolve before you go and write code. But what most people don't understand is if you get this first part well, the second part of writing and designing the code will take you less time. So it's like 80-20 principle. So focus on understanding requirements from the business, interpreting them and explaining them to the non-business, to the non-technical people. Again, it can generate diagrams and draft, but it cannot sit in a meeting. It cannot ask the right hard questions and push back on unrealistic expectations the way a good engineer would do. Oftentimes, I'm being in situations where the business will ask for a requirement. And I know that deep down in the code, we cannot meet those requirements in their timeline. I'm not sure I can do that. How soon I can do it. But you as a good engineer should be able to do that. So if you combine solid fundamentals with these AI tools, you become extremely productive and not just redundant. So if you work in a small team, what you used to take you maybe 2 sprints or 3 sprints to achieve, you can achieve them in half of the sprint. That's currently happening to me today. Now you'd have noticed a pattern. Whether you choose medicine or engineering, the game is the same. Then they call human skills. I would say this is the most important part. Learn the core human skills in your field. Then learn the AI tools early. Pick the ones that you like and learn them early. Treat AI like a collaborator, whose work you would review, and don't make it a boss who will tell you what to do. It should be the other way around. Here's a simple self-check you can use. If AI disappears tomorrow, would you still understand what you're doing? If the answer is yes, and AI is just making you faster and more thorough, you're using it the right way. Kudos to you. But if the answer is no, if you're basically just pushing AI buttons, you are in a fragile position, no matter what degree you have. In my own case, when I started using to assist in writing code for Clothing, which is a mobile app for buying fashion that I'm working on, it made me move faster. But it's because I was already building software for many years before we had LLMs or any AI coding tool. I already knew how AI works because I was building a vision model to generate fashion sizes from two photos or from simple inputs, and then uses the sizes to match fashion product in your city. So if you use the app and you open it up, every fashion piece you see on the app, it's a mobile app, will be clothes that fit you in your city. If you want to learn more about this application that I'm working on, which I encourage you to do, you can check the link in the description. To take you to a website and then you can read about all the information. I'm still in the process of finalizing the app just to check to ensure that there are no bugs. So for now, you can just sign up to be an early user. So to the young man who left me that comment and anyone else in the same spot, what I say to you is this: do not pick a degree just because you think it's AI proof. Pick a problem space you actually care about. Do you want to help people one on one in moments that really matters? Medicine might be your path. Do you want to design complex systems and build infrastructure that runs everything? Engineering might be your path. Whichever you choose, commit to becoming the kind of person that AI makes more powerful, not someone who is competing with AI. If this helps you think about your future a bit differently, let me know in the comments what field you're leaning towards and how you plan to use AI to be more productive. And if you're already in medicine or engineering, share how you're using AI right now. That will help a lot of people watching this video. Thanks for watching, and I'll see you in the next one. Take care and stay strong. Bye bye.